Hello, Year 12. Mr. Stevens here. Today will mark the beginning of our work on a new unit called Scale Drawings. The topic that we're starting off with is ratios. When we're talking about scale drawings, what we're going to be working with a lot is ratios. So before we can start doing anything with the drawings and plans and maps and stuff like that, we need to make sure we're familiar with ratios. And especially what's going to be interesting to us is making sure we've written them in the simplest form we possibly can. The ratio that I think a lot of you might be familiar with, you may have heard this 16:9 aspect ratio on a widescreen TV. Ratios in general are used to compare amounts of the same units in a definite order. Okay, what that means in terms of an aspect ratio is this 16:9. For every 9 pixels that go down the screen this way, there are 19 pixels that go across the screen this way. It's the unit is how many pixels there are on the screen, and the order is that 9 go down for every 16 that go across. I think you would probably be familiar with on maps and things like that. They might have a scale that looks like this. There'll be a centimeter there and it'll say a distance here. Maybe that distance is 100 meters, something like that. And you would write that ratio as 1 meter to 100. Or sorry, it would be 1 centimeter to 100 meters. Intuitively, I guess what I'm saying is that you should have an idea of ratios and what they are, but we're just going to drill down on a couple of concepts that will help us work with them more easily. And the first is simplifying a ratio. And essentially what's happening here is this is exactly like simplifying a fraction. What we want to do is we want to find the highest common factor of 20 and 4. Now, what the highest common factor is, if you don't remember, is the largest number it's the largest number we can divide both 20 and 4 by and still get a whole number solution. That's an important part. So in this case, 20 and 4, what number can we divide by 20 and divide by 4 and still get a whole number answer? The highest common factor here is actually 4. Okay? In this case, it's 4. So we're going to take 20 and divide it by 4, and we're going to take 4 and divide it by 4. And we'll end up with 5 to 1. Okay, in the same way that you can take a fraction, multiply it by the same number, and get an equivalent fraction. These two fractions have the same value with different numbers. We can do the same thing with ratios. These two ratios are made up of different numbers, but they have the same value. 20 to 4 is the same as 5 to 1. Alright, looking at these next few examples, we have ratios that have fractions and decimals in them. To write these in the simplest form, we just want to make it so that they're whole numbers. Okay, so if you have a fraction like this in your ratio, all you need to do to get rid of the fraction is multiply both sides by whatever's on the denominator. And we end up with 6 to 1. In this case, And there are a few ways you can go about it. I think the simplest one is to times both sides by 10 and make it so they are no longer decimals. And now we follow the same process that we did over here, where looking for the highest common factor of 15 and 35, what's the largest number we can possibly divide by both of these? The answer here is 5, and then we go and divide both of them by 5. And now this ratio is also in the simplest form. If you want some help with identifying the highest common factor of a pair of numbers, make sure you let me know, and I will give you something you can go over that will help you with that. But for now, you guys are going to go back to our textbook now, page 191. For the first 5 questions, each of them have a number of parts. I want you to do 3 parts per question. And then there's a list of questions here for you to complete from the remainder of the exercise. Thanks, guys.